this is the homework 5 problem 1. So x, y, and y are independent. So it's already told us it's independent with fx, x equal to step function x minus 1 minus step function x minus 2. Density function y equal to step function y minus step function y minus 1. And z equal to x plus 1, x plus y. Find the xz density function of z. So we need to find it by two-way convolution method and a geometric method. So I want to do the geometrical approach first. So we can see we can do, since the question, the two formula is step function x minus 1 minus x minus 2, and the second one is 1 and 1 minus 1. So let's see in this one we can see we will try to do it first. For the density function of x, I will try to do ux minus step function x minus step function x minus 1 first, and we will see later. We just need to shift to right. So for this function, if we just use ux minus ux minus 1, we will see this three picture. So basically for the step function x minus step function x minus 1, we can see when x equal to 0, it will be use step function equal to, it's a step function here, and also a step function here. So both of them do the convolution. We will see it will be like this one. Once increase, when the function slides here, and after it will be something like this, and the final it will be something like this, and the total graph looks like this one. So basically, we will see that should the geometrical approach we will see here, and for the function, we can see z is equal to x plus y, and then we put it in the two-dimension, and we can see for the x and the y. So we'll see, since we first calculate by the step function x minus step function x minus 1, so basically we can draw a square here, it's equal to 1 and 1, and then we know that it's equal to x plus 1. So we can easily draw it like this formula, like this, plotted this line. So we need to just discuss what's value of the and it is different formula. So basically, when z is less than 1, and we can see for z is less than 1, this part should be, so for fz is equal to the probability z is less, the event z is less than z. So basically I can plug in the x plus y is less than z. So it's equal to x equal to z squared divided by 2, which is this part. So it's a triangle, and both there's two sides is equal to z, and this is right corner. So basically it's a triangle, and it's equal to z squared divided by 2. Also, what's this also equal to the prime of the distribution function, so it's equal to z. The density function, this part is equal to z. So for the part like here, so basically the when z is greater than 1 and less or equal to than 2, so basically the area, the distribution function's area of this part. And which it's a big triangle, and there's two small triangle we need to remove. So basically, we also can see like use the same as distribution of z is equal to the probability z is less than equal to z, and plug in the x plus y is less equal than z. So basically, this part is the same as the triangle since it's z. And for the here, this part, so I need to mention here is z and z here. So this small triangle, it has two sides, is 0 minus 1 and 0 minus 1. So here, same thing, 0 minus 1, 0 minus 1. Since this is x equal to y, this part is x equal to y. So it's simplify this formula, and we get negative c squared over 2 plus 2z minus 1, and we do the prime derivative, so it's c prime. Here it's just a negative z, and this part is remove the z after the derivative, remove the z is just 2, and it's constant, and we just ignore that. So for the last part, when the z is greater than 2, so basically that part, this one is greater than 2, which is here. So basically there's no after that part, after this part, after 2, z equal to 2, is the probability of z is less than z is equal to 1. And the density function, when it's already constant, is just equal to 0. So for this one, we use the geometric approach. We can get this graph from the start as a FCX. So we can see, let's say, start with z and negative z plus 2 and 0. So from here, this is z. So it start with a 0. When z equal to 0, it's equal to 0. And once z equal to 1, it's equal to 1. And when z equal to 2, it's the same thing here. It's less than or equal to 2. Okay. And after 2, it's just a 0. So that's the graph for if we use fx equal to ux minus step function x minus ux minus 1. So after that, since the original question is the question is about here is I will write it down. The original question is f(x) x equal to u x minus 1 minus u x minus 2. So for this part, we need to shift the graph to right. So this one is also z, as for z is 0. So that will be the final formula for this question. And for the geometric convolution approach, so we can see here we use same thing like we will use ux minus 1 first, and after that we will shift the result to the right side by 1. And here, so we can see we try to use the convolution formula. So we can see here fc equal to fc fxz times fyz, convolution fyz, and we can use the formula mentioned in the question. And basically, we just replace the value here, a and z minus a. For this question, since we have same function for the density function for this one, since we already simplify it with simplify the density function of x. So basically they are the same. We don't need to worry about choose which one. And we just plug in the function. So use the step function, and we can see it's here. To simplify, we can see here, and there's a 4 part. There's a 1 part, 2nd part, 3rd part, and 4th part. They can be separated, and for here, so basically we need, since it's on A, and we can do it. So we can see like the range of A. So for this part, so we can see for A we need this works as its meaning. So basically A is from 0, and for this part A is from the limitation of this is less or equal to Z. So basically for this part we can see it's 0 to Z, and we have to times uz. This part is defined by the z minus 0, the step function z minus 0. And also we can see after that, we can see here the same thing here, 0 and z minus 1 minus a, which means the range of a can be 0 to z minus 1. And also we need to make sure this part is also greater than 0, greater equal to 0. And also this part for the step function, same thing, the variable will be z minus 1 minus 0. So same here, 0 to z, and here is different. Here is z a minus 1 is equal to, yeah, here's something different. This part should be 1. And here is z minus 1. And then we can see here, so basically this part gives us z minus 2. So after that, we can see here, so all of them become, since we see it's all 1, and it's all some values as 1. So basically, just use plugging the derivative. It's so alpha z minus 0 is 0 z times uz minus the same here, alpha is z minus 1 minus 0 is same thing here, and z minus 1 same thing, and we got the final function here, which is similar with here. So we can see for z it's from 0 and it's 0. So for both of them here, since this part is 0, it's negative, but for this one, since z minus 0 minus 1 is -1, the step function of -1 is 0. And here it's also 0, 0, 0. And for z equal to 1, so we can see here is 1 minus, it doesn't matter, since that's the first part is 1 minus 1. So I think here it's negative 0, so it's keep it 1. So here also is 0 for the 1 minus 2 is negative. So step of function of negative value is 0. And here is 0, here it is. So after that, so for the here's something wrong. So basically it should be x. And after that, if it should be x. Should be, yeah, it should be x. After that, so this figure need to move to right 1 unit. So same thing here. Okay, that's question 1.